Alcohol at the cellular level, the beautiful lie. Let's start with what alcohol actually is. There are three main types: isopropyl, methyl, and ethyl alcohol. Only the last one, ethyl alcohol, or ethanol, is safe for human consumption. And safe here is misleading, because ethanol is still a toxin. Chemically, ethanol is special because it's both water-soluble and fat-soluble. That means it can pass through almost every barrier in your body. Many substances like certain vitamins or medications can only move through water-based areas, or only through fat-based areas. Ethanol? It slides right through both. That's why, when you drink, alcohol doesn't just stay in your stomach. It seeps into your blood, crosses into your organs, and critically passes straight through the blood-brain barrier. No paperwork. No security check. It goes anywhere it wants. Your body's emergency plan. Your body knows ethanol is toxic, so it tries to neutralize it immediately. This process mostly happens in your liver. Step 1: ethanol is converted into acetaldehyde. Here's the kicker: acetaldehyde is even more toxic than ethanol. It's a cellular wrecking ball, damaging proteins, DNA, and the delicate machinery inside your cells. Step 2: your body scrambles to convert acetaldehyde into acetate, a less harmful molecule your cells can actually use for energy. But acetate is empty calories. It gives you fuel without any vitamins, minerals, or nutrients. No benefit, just energy your body can't really store for later. This conversion relies on a molecule called NAD, nicotinamide adenine dinucleotide. You may have heard of NAD in longevity research. Higher levels are linked to better cellular health and potentially longer lifespan. Unfortunately, when you drink, your NAD gets pulled into alcohol detox duty, leaving less available for repairing your cells or supporting healthy metabolism. The first lie alcohol tells your brain: that warm, relaxed buzz after your first drink? That's not happiness in the way most people think. It's your neurons reacting to a poison. When alcohol enters the brain, it doesn't politely bind to one receptor and trigger one signal, like many drugs do. It just slips into the cells, altering how they function across multiple brain areas all at once. It's chaos, but a chaos your brain interprets as lowered inhibition, boosted mood, and temporary confidence. But here's the twist: this same process is also setting you up for the crash that follows. Because the good feeling isn't a reward, it's your brain's chemistry being knocked off balance. And once that balance tips, your body has to overcorrect, which is why the hours after drinking often feel more anxious, irritable, or flat. The red flag you might not recognize. Some people get tipsy and tired after just a couple drinks. Others, and this is key, feel more energized, more alive, the more they drink. If you're in that second group, pay attention. Studies show that people who feel energized instead of sedated as they drink are far more likely to develop alcohol dependence. It's not about willpower, it's about how your brain's reward circuitry is wired. If alcohol makes you feel increasingly good the longer you drink, your brain is more likely to chase that state again and again. Up next, we're going to zoom in on the brain regions alcohol targets, why your voice gets louder, why you say things you regret, and why your memory might go missing after a night out. Because once you understand what alcohol does to your prefrontal cortex and your hippocampus, you'll see why just a little is never as harmless as it feels in the moment. The brain on alcohol: what really happens in your head. Imagine your brain as a city at night. The prefrontal cortex, the part right behind your forehead, is City Hall. It's where decisions are weighed, rules are enforced, and impulsive ideas are either greenlit or shut down. When alcohol arrives, City Hall dims the lights. The officials start leaving early. And without their oversight, the rest of the city starts acting out. Why your voice gets louder. The prefrontal cortex normally helps you regulate how loudly you talk, how close you stand to someone, what you say and when you say it. Under alcohol's influence, that self-monitoring system powers down. Your volume control slips, your gestures get bigger, and you become less aware of how you're coming across. Ever stepped outside a noisy bar and suddenly realized you'd been shouting? That's your prefrontal cortex waking back up, and it's why your throat might be sore the next day even if you never sang a note. Impulse on overdrive. Your prefrontal cortex also applies brakes to your impulses. Without it running at full strength, the parts of your brain that generate spontaneous actions, I'm going to say this, I'm going to dance now, I'm going to text my ex, have free reign. That's why you might say things you'd never normally say, take risks you wouldn't normally take, or agree to things you'll later regret. It's not that you've become someone else, it's that the part of you that normally filters and edits your behavior has gone temporarily offline. Memory under siege. The hippocampus effect. The hippocampus, deep inside your brain, is like a librarian. It takes the raw footage of your daily life and files it into long-term storage. Alcohol makes that librarian fall asleep on the job. While you can still talk, move, and interact, your brain may not be recording those moments properly. That's why you can have a conversation, make decisions, even travel home but wake up the next day with no recollection of it. This isn't forgetting in the normal sense. The memories were never stored in the first place. This is the neuroscience of a blackout, and it can happen without passing out. You can be wide awake, walking, and talking, but creating no lasting record of what you're doing. Two types of drinkers, two very different nights. Here's where it gets especially important for self-awareness. There are generally two types of drinkers. Sedated drinkers. After a few drinks, they slow down, get sleepy, and eventually stop. Energized drinkers. After a few drinks, they feel even more alive, chatty, and upbeat. If you're in the second category, research shows you have a higher genetic risk for developing alcohol dependence. That energizing effect is a sign your brain is wired to get a stronger reward signal from alcohol, which can pull you back to it more often and in larger amounts. The long game, changes that last beyond the buzz. One of alcohol's least discussed dangers is how repeated drinking, even just once a week, rewires your brain over time. Neural circuits for habitual and impulsive behavior grow stronger, while circuits for flexible decision-making weaken. Translation: the more you drink, the easier it becomes to act out of habit instead of thought. And this shift doesn't just happen while you're drinking, it can carry over into your sober life, making you more impulsive day to day. The good news for most people, these changes can be reversed with 2 to 6 months of abstinence. But the longer and heavier the drinking history, the slower and less complete that recovery becomes. Next, we're going to talk about alcohol and your stress system, how drinking to relax might be programming your body to feel more stressed when you're sober, and why this is one of the biggest traps regular drinkers fall into. To be continued on Part 2.